Let a of n be an arithmetic progression with a1 equal to 7 and an plus 1 minus an equal to 8. Let t of n be another sequence such that t1 is equal to 3 and tn plus 1 minus tn is equal to an. Which of the following best defines tn for all n greater or equal to 1? Option A, option B, option C, option D, and option E. Now this question was the very first question that featured in the mathematics section of the engineering section of the National Olympiad for the Grades Academy that was written 2 days ago at the Faculty of Medicine and Biomedical Sciences of the University of Yaoundé 1. So we are going to have a rundown of this question, and for those of you who are just joining us, endeavor to subscribe to the channel, share the video after watching, give a like to the video if the video is good, and subscribe to the channel. So let's get started. So we have been given the sequence E of n and T of n, and we have given some other informations. So let us begin with the information which says that the difference between the n plus 1 term and the n term of T of n is the sequence A of n. Now, having this difference, we can take one step behind. We get T of n minus T of n minus 1 to give us A of n minus 1. We can take another step behind. We get T of n minus 1 minus T of n minus 2 to give us A of n minus 2. We can take another step behind. We get T of n minus 2 minus T of n minus 3 to give us A of n minus 3. We continue taking steps behind until we arrive at the position where we have T2 minus T1 to be equal to A1. Now, if we add up all these equations, we are going to see that T of n is going to cancel off, because here we get negative T of n plus T of n. It cancels. T of n minus 1 cancels as well, because we get negative Tn minus 1 plus Tn minus 1 is 0. We get T of n minus 2 also cancels. Definitely T of n minus 3 will cancel. T2 as well is going to cancel, and we are going to be left with Tn plus 1 and negative Tn. So what do we see? We see that the left hand side, adding everything, we just get the first and the last term. So we term this sequence or this sum a telescopic sum. So we get Tn plus 1 minus Tn to be equal to the sum of the right hand side. So we start summing from the first term right up till the end term of an. So we get a1 plus a2 plus a3 right up till an. Now, since we have that an plus 1 minus an is equal to 8, it means that an is it is an arithmetic sequence. So with that, the sum of the first n terms is simply the number of terms divided by 2 multiplied by the sum of the first term and the last term. But the last term is simply an, and we can get that n term actually. The first term is 7. Now we further proceed to get A of n. Since it's arithmetic, it means it can be written as the first term plus the common difference times the number of terms minus 1. Now we have the first term as 7, we have the common difference as 8, because the common difference is the difference between the n plus 1 term and the n term. Then we get simplify, we get our A of n to be 8n minus 1. We refit here, we get T of n plus 1 minus T1 to be n on 2 into 7 plus 8n minus 1. We simplify, and we can divide all through by 2. We get n into 4n plus 3. Remember, we need T of n, so we need to add T1 on both sides of the equation. But our T1 is 3, so we get, if we expand this, we get 4n squared plus 3n plus T1, but our T1 is 3. So it means that the n plus 1 term of T is 4n squared plus 3n plus 3. But we need the n term, so we need to take one step behind. So in the place of n, I replace it with n minus 1, that's taking one step behind. In the place of n, I replace it with n minus 1. So with that, I can expand, and then I group like terms together, and at the end I get my sequence T of n to be 4n squared minus 5n plus 4. This is a quadratic sequence, and option B is correct. So for those of you who are just joining us, like I said, endeavor to subscribe to the channel, turn on your notifications so that whenever videos are uploaded, you always be notified to come and watch. Share the video with your friends, like the video, and also comment. Thank you, and see you in the next video.